In stats, we pressed on and we worked through 2 sample t-tests. We will start the same exact way. We'll define both groups. This time we are talking about means, which is why we're doing t-tests. We're working with numerical data, with categorical data, proportions, we're doing Z. But when we have numerical data, we typically use T, and I'll talk about why more specifically in a little bit. So you define both groups and the true mean of whatever it is you're studying. Set up your 2 hypotheses. And this is very similar to 2 proportion z-test. We assume the 2 means are equal. And we're testing to see if one is smaller, larger, or just not equal to the other. Make sure you set alpha up here in the state step or the hypothesis step. So make sure you say what it's supposed to be. And then move on to the plan step. So plan step is really similar, but one difference from 2 prop z tests. So you need to have random samples, although that's not always the case. Or random assignment. This time we're not doing large counts. You know, when we had proportions, you had to make sure your sample was large enough in regards to the proportion. So you check this and you check the complement. And if those checked out, it was normal. That was proportions. For means, you have 3 scenarios to determine if it's normal. So the first one is nice, but pretty rare. It is stated as normal. Like they literally say the distribution is normal. That means sample size does not matter. Usually they don't say whether it's normal or not. But the ideal scenario is, or actually another ideal scenario is if n is large. So this time we have 2 samples and hopefully they're larger than 30. If they're not larger than 30 and they don't come out and tell you it's normal, so it's small, but the graph or graphs look symmetric with no outliers. And I'm realizing I didn't give myself enough room. So we have 3 conditions for the plan step. Condition 1, condition 2, condition 3 is the 2 samples need to be smaller than 10% of the population. So you need to check all 3 of those. For the do step, the math step, or calculator step, let's move that. We are going to do a 2 sample t-test. And you are welcome to just write that, or you can write the formula. The formula is not any fun, but write one of these 2 things, the name or this formula. You'll grab your calculator and you're going to get a ton of results, a ton of stats printed out. One of them is degrees of freedom. this monster right here. When we had one sample, it was just n minus 1. Now that we have two samples, there are more things happening. It's more complicated. You do not need to memorize this. You're just going to run the test on your calculator, and it'll output DF, and you just write down what it is. So you do not need to memorize this. All right? But please write down everything the calculator outputs. It's going to give you the two sample means, the two sample standard deviations. It'll give you T, it'll give you DF, and it'll give you the p-value. So you need to make sure you write all of that down. Compare the p-value to alpha. Is it smaller or larger than alpha? You're going to end up rejecting or fail to reject. Use context. All right, there's a couple more things on this page that I want to point out. It's going to ask you a question, do you pool it or not? And I have never seen them ask you to pool it. So if they somehow, like in the paragraph, imply that standard deviations are equal, then you're supposed to say yes. But they never do. It's not going to happen. It's a rare occasion. They have never asked you to pool it on a previous AP test. They have never asked for the data to be pooled in the past. Like it's a real rule and it could happen, but I'm just telling you they never have. It is very likely, very, very likely, you just say no. Some teachers teach no matter what, say no. I don't like to say no matter what. Like if they clearly say we can assume standard deviations are equal, then you're going to say yes. All right? But they're not going to. It's not going to happen, and we're going to say no. The other thing is, why are we using T? We answered this a few weeks ago. It's because we do not have or know the population standard deviation. Sigma. We don't have it. It's not the researcher's fault. They just have a lack of information. We only have the sample standard deviation. S. So S is a little more variable than the true population standard deviation. It's not precise, and likewise, same with T. T is pretty powerful, and it's a good distribution to use, but it's more variable than Z. Z is like your perfect bell curve, and if we knew sigma, we would be using Z, but like 99.9% of the time, we only have S to work with, which forces us to use T. All right, let's give one a try. We have this learning style problem. Maybe hit pause and skim through it. Here we go. True mean, science grade. For first-year nursing students, using conventional study methods. You can say more if you want, but I think that is plenty. Group 2, true mean science grade for first-year nursing students. Using homework prescriptions. Based on learning style. All right, we got our two groups. I probably wrote too large. I hope I have enough room. Our two hypotheses are assume group 1 is equal to group 2. And they suspect that these homework prescriptions are improving science grades. So we think group 2 is going to have a higher mean. They give us a pretty unique or small alpha value. Alpha is 0.1. These are not random nursing students. They're just those that are enrolled are randomly assigned. So that's all we can talk about. Random assignment to groups. The sample sizes are great, right? Both are larger than 30. Sampling distribution is approximately normal. The sample size we're going to have to assume is smaller than 10, I guess I should write this specifically, smaller than 10% of the population. Interestingly, like I almost wrote it, but I don't want people to be confused. This is just one population of first-year nursing students. So the sub numbers N1 and N2 doesn't really make sense there, but it's fine. Assume true. It's probably true. All right, we're going to run the test on the calculator. We're doing a 2-sample t-test. Make sure you write down all the statistics that it outputs. We're writing those two things, the 2-sample standard deviations. We're writing down T, DF, and ultimately we are writing the p-value. So I'm going to run it on my calculator. I forgot to bring it over. Here it is. We go to menu, stats, stat tests, and we want 2-sample t-test. This time we have stats. We don't have a list of data values. We just have stats. And I've forgotten what these are. 275, 0.85, 100, 3.28, 0.7, 103, We think mu1 is smaller, and there's the pooled question. Leave it as no. All right, we need to write things down, but we're about done. We have all our results. So we know 275, 328, 0.85, 0.7, negative 4.8418, 191.6 degrees of freedom. We know the proportion of t's smaller than negative 48418 is approximately 0. P is less than alpha. That causes us to reject. I'm going to use a different color. Reject HO. Evidence suggests the true mean science grade for first year nursing students receiving homework prescriptions by learning style is higher than with conventional study methods. All right, I hope you had a tad more room than I did. I hope that makes sense. I will see y'all later. Bye.